Hello everyone, welcome to the lecture again. In the last lecture, we look at the definition of friction, the kinetic friction and the static friction. We also solve couple of examples. Today, we are going to look at more examples about the friction. So, let me first write down the first problem statement. The question statement is determine the distance s to which the 90 kg painter can climb without causing the 4-meter ladder to slip at its lower end A. The top of the 15 kg ladder has a small roller and at the ground the coefficient of static friction is 0.25. And it is also given that the mass center of the painter is directly above her feet. So, to solve this question, let us first make the free body diagram. So, we have the ground and the wall, and this is the ladder. This point is A, this point is B. At A, there will be a force Ay and Ax. At B, since there is no friction and there is a roller, so therefore, the reaction force will be in the x direction. It is also given that this is 1.5 meter, this is 4 meter. Therefore, this length will be square root 4 square minus 1.5 whole square, which comes out to be 3.7 meter. Now, the weight of the ladder will act at the center and it is 15 multiplied by z. So, therefore, 15 g and the weight of the painter is acting at a distance of s, which we have to determine, and it is 90 into g. Let us say this angle is theta. So, we can balance the forces in the x and the y direction. So, from here we have a y is equal to 90 g plus 15 g. So, 90 plus 15 into g, and this comes out to be 1030 Newton. Now, the value of Ax, this is because of the friction. So, either you can write down Ax or you can write down the frictional forces. Its value will be mu times n. So, therefore, it will be mu times Ay. Okay. And of course, this is the maximum value of the friction. Okay. So, this you can write down because now Ay I know and mu is 0.25, it is given multiplied by Ay. Now, to find out S, what we can do is we can take the moment about B. So, therefore, Bx will not contribute. So, let us take the moment about B. So, we have 15 g force multiplied by the perpendicular distance. Since this whole distance is 1.5 meter, therefore, this will be 0.75 meter. So, 15 into 0.75 plus we have 90 g weight, and this has to be multiplied by the perpendicular distance. So, this distance, at this will be 1.5 minus this distance, and it will be s cos theta. Okay. Plus we have 0.25 into 1030 into 4 sin theta, okay, because the value of Ax is 0.25 Ay and Ay is 10330 and the perpendicular distance is 4 sin theta. So, this has to be equal to 1.5 into 1030, and this gives you, because cos theta is also known, g is also known. So, this gives you s equal to 2.55 meter. Okay. So, this was the example of a leaning ladder. Now, let us look at one more question wherein the ladder is at the corner. The problem statement is following: a ladder of mass m and length L leans against a frictionless wall with a quarter of its length hanging over a corner. It makes an angle theta with the horizontal, and in the question it has asked what will be the angle theta that require the smallest coefficient of friction at the corner to keep the ladder at rest. So, we have to find out the smallest value of mu, and from there we have to find out what is that angle theta. So, let me again make the free body diagram of this. Okay. This length is L by 4, and the reaction forces are going to act in the following way. So, from here there will be a normal force, let us say this is NC, C for corner, and there will be a frictional force. So, because the impending motion of this ladder will be downward, therefore, let us say that the frictional forces are like that, and let me call it FC, C for corner. This point is of course given as C. Therefore, since the entire length is L, its weight is going to act at the middle. So, this will be mg. So, therefore, this length will also be L by 4 and this will be therefore L by 2. Because the vertical wall is frictionless, therefore, there will be only the horizontal component. So, let me call it NW. Okay. Now, this is the free body diagram. It is also given that this angle theta that we have to find, therefore, this angle will also be theta. Let me fix the coordinate axis. So, let us say this is x axis, this one is the y axis, therefore, this angle will also be theta from the geometry. So, first let us take the moment about W. In that case, we have NC into the perpendicular distance, which is 3L divided by 4, equal to, we have mg into L by 2 cos theta. Note that the contribution of NW will not be there because we have taken the moment about W. Similarly, let us take the moment about C. So, we have mg into L by 4 cos theta equal to NW into 3L divided by 4 sin theta. Let us call it equation number 2, and again note that since we have taken the moment about C, therefore, the contribution of NC will not be there. Now, to find out the relation among them, let us take or let us balance the forces along the x axis. Okay. So, let me say that summation Fx equal to 0, and let us say we are balancing this at point C. Okay. So, we have Fc, the frictional force, its component along the x axis is cos theta, equal to, we have Nc force and its component. So, it will be mg cos theta divided by 3 sin theta plus 2 by 3 mg cos theta into sin theta. So, I have balanced the forces along the x axis, and the value of Nc and the value of Nw I have taken from equation number 1 and 2, and then take the component along the x axis. From here I can find out what is Fc, the frictional force. Frictional force Fc will be mg over 3 sin theta plus 2 over 3 mg sin theta, and we know that the frictional forces has to be less than equal to mu times the perpendicular reaction that we have. So, therefore, mu times Nc. Okay. So, this is the definition of the frictional force. Therefore, we can write down mg over 3 sin theta plus 2 over 3 mg sin theta must be less than Nc. Nc again we can write down from equation number 1, and we have mu into Nc is 2 by 3 mg cos theta. This gives me a relation between mu and theta. So, mg will get cancelled, and we can rewrite this as mu must be larger than equal to 1 over 2 sin theta cos theta plus sin theta over cos theta. Okay. Let me call this function as f theta, and to find out what is the minimum value of this mu, we have to minimize this function, and that will give us theta. So, to minimize this function, df over d theta should be equal to 0. So, let us calculate the differentiation of this. So, we have f theta equal to, I am just rewriting this, it will be tan theta. So, sin theta over cos theta is tan theta plus cosec 2 theta. Okay. So, let us minimize this, df over d theta will be equal to sec square theta minus 2 cot 2 theta cosec 2 theta, and this should be equal to 0. Therefore, sec square theta will be 2 cot 2 theta cosec 2 theta, and this I can rewrite as 1 over cos square theta equal to 2 cos 2 theta over sin 2 theta into 1 over sin 2 theta. Therefore, 1 over cos square theta becomes 2 into cos 2a is 1 minus 2 sin square theta over 2 sin theta cos theta into 2 sin theta cos theta. Cos square theta will cancel, these 2 cos theta, 2 will get cancelled with 2, and we have 2 sin square theta equal to 1 minus 2 sin square theta. Therefore, 4 sin square theta equal to 1 or sin square theta equal to 1 by 4. Therefore, sin theta is equal to 1 by 2, and this gives you theta equal to 30 degree. That means that for this theta equal to 30 degree, our mu will be minima, and this is the problem statement to find out theta for which the coefficient of friction is smallest. Now, let us look at another problem statement, and it is following. The coefficient of static friction for all contact surfaces in figure is 0.2. Does the 50 Newton force move the block A up, hold it in equilibrium, or is it too small to prevent A from coming down and B from moving out? To find out whether the 50 Newton force will move the block A up or downwards, let us find out the force that is required to push the block inside or to pull the block outside. So, for that, let us make the free body diagram for impending motion of the block B to the left. Okay. Let me make the free body diagram of block A. So, this is for block A. From the wall there will be a reaction force, let me call it N1, and since block B we are assuming or we are pretending that it is moving inward, therefore, the block A is going to lift up, therefore, the frictional force will be downwards and it will be 0.2 times N1 because mu is 0.2. Its weight is given, it is 200 Newton, and when the block B is going to move in, the reaction force on it will be upward, therefore, on block A it will be downwards. So, this is how the frictional force on block A is going to act. Let us say its normal force is N2. Therefore, this will be 0.2 times N2. Now, to find out what is the value of N1 and N2, let us balance the forces along the x and y direction. So, summation Fx equal to 0. This gives me N1 equal to, now it is also given that this angle is 15 degree. So, therefore, it will be 0.2 n2 cos 15 degree plus n2 sin 15 degree. Let us call it equation number 1. Now, let us balance the forces along the y direction. So, along the y direction we have 200 Newton force, its weight, plus 0.2 into n1, that is also acting downwards, plus 0.2 n2 sin 15 degree equal to n2 cos 15 degree. So, from equation number 1 and equation number 2, we have two unknown and rest of the parameters are given. So, therefore, from 1 and 2 we can find out n1 and n2, and n1 comes out to be 109.8 Newton and n2 comes out to be 243 Newton. Now, let us look at block B. So, this is the free body diagram of block B. So, external force P is acting on it, N3 will act upward, its weight is given, it is 100 Newton. Now, as I said, we are pretending that the block is moving to the left, therefore, its frictional force will be like that and it will be 0.2 times N3, and here you will have 0.2 into N2 because we have normal force N2, and of course, it is acting at 15 degree. This completes the free body diagram of that. Now, again let us balance the forces in the x and y direction. Summation Fx equal to 0, this is for block B. Summation Fx equal to 0 gives you P is equal to 0.2 N3 plus 0.2 N2 cos 15 degree plus N2 sin 15 degree. Let us call it equation number 3, and then we have summation Fy equal to 0, that gives you N3 plus 0.2 N2 sin 15 degree equal to 100 plus N2 cos 15 degree. Let us call it equation number 4. Again, now from equation number 3 and 4 you can find out what is the value of P, and it comes out to be 174 Newton. Okay. Now, in the question statement it has given that P was 50 Newton, therefore, this 50 Newton force is not sufficient to push this block inside, because just now we have calculated that the value for P should be 174 Newton. Okay. So, this implies that force of 50 Newton is insufficient to induce a motion of block B to the left. Now, let us reverse the direction of the force and find out what is the force that is required to pull this block out. So, now let us reverse the direction of P and calculate its value to move the block B to the right. Okay. So, note that the only changes that are going to happen is the direction of N2 and N1 are going to reverse. Okay. So, in the previous part, wherever you have point to N2, this will becomes minus point to N2 and point to N1 will become minus point to N1, because the direction of the frictions are going to change. So, let me just write down for block A. Now, the equation will be summation Fx equal to 0. You can look at this equation, and as I said, the direction of the frictional force are going to change, and of course, P also we have reverse. So, therefore, N1 will be minus 0.2 N2 cos 15 degree plus N2 sin 15 degree. Let us say this is equation number 5, and then we have summation f y equal to 0. So, you have 200 minus 0.2 N1 minus 0.2 N2 sin 15 degree equal to N2 cos 15 degree, equation number 6, and from 5 and 6 you can find out again what is the value of N2 and N1. So, you get N2 equal to 194.1 Newton and N1 equal to 12.80 Newton. So, for block B, again we can use equation number 3 and 4, and we can change the direction of the frictional forces. So, this will be P is equal to 0.2 N3 plus 0.2 N2 cos 15 minus N2 sin 15, let me call it equation number 7, and we have N3 minus 0.2 N2 sin 15 degree equal to 100 plus N2 cos 15 degree. Let us say this is equation number 8, and again from 7 and 8, as we have done in the last part, you can find out what is P, and you can see that P will be 46.7 Newton. So, this implies that we have to pull to the right with this 46.7 Newton force to get block B to move in this direction. Okay. Therefore, the block are in equilibrium. Okay. Because to pull the block we need 46.7 Newton force, and to push the block we need 174.7 Newton force, and we are applying only 50 Newton force. Therefore, the block will be in equilibrium. Now, let us look at one more question on the same concept, and the problem statement is following. The coefficient of static friction mu s between the 100 kg body and the 15 degree wedge is 0.20. Determine the magnitude of the force P required to begin raising the 100 kg body if A rulers of negligible friction are present, under the wedge, as shown, and B, the rollers are removed and coefficient of static friction mu equal to 0.20 applies at this surface as well. The concept of this question is same as the previous question. So, here we have these rollers and we have a block which is being raised by applying a force P. The weight of this block is 100 kg. Let us call it block A and let us call it block B. So, in the question statement we has asked to find out what is the value of P so that the 100 kg block is getting lifted. Okay. So, let us look at the free body diagram of block A. Okay. So, we have the following situation. Note that at these ends we have a roller support, therefore, there is no friction. So, we have only R1 let us say and R2 force. Since this block B is having a impending motion towards the left, therefore, the friction on block A will be like this and its value will be mu times R3, where R3 is the normal reaction. The weight of the block is of course going to act downwards and it is given that it is 100 kg. So, therefore, weight will be 100 times g. Okay. This angle is of course 15 degree. So, let us balance the forces along the y direction. Summation Fy equal to 0. So, we have 100 into g plus 0.2 R3 into sine 15 degree, because this angle will also be 15 degree and the friction is 0.2. So, it will be 0.2 R3 sine 15 equal to R3 cos 15 degree, and we know the value of sine 15 and cos 15. So, this gives you R3 and R3 comes out to be 1073.2 Newton. Now, let us look at block B. So, this is the free body diagram of block B. The force P is acting on it, therefore, the impending motion on block B will be left, therefore, the frictional force are going to act upward mu times R3, where R3 is the normal force, and from the bottom there is going to act a reaction force R4. There is no frictional force because it is a roller support and it is frictionless. So, let me balance the force along the x direction. Summation Fx equal to 0. So, we have P equal to mu times R3 cos 15 degree, because this angle is 15 degree, plus R3 sine 15 degree, and again the value of R3 is known, the value of mu we know, and cos 15 and sine 15 also we know, therefore, P comes out to be 485.08 Newton. That means, we require this much force to move this block towards the left. Part B, wherein the rollers are removed and replaced by a frictional surface, you can take it as a homework problem, and the final answer for part B is P equal to 681 Newton. With this, let me stop here. See you in the next class. Thank you.